Today is the 24th of May 2024. Okay, and this will be our 8th video on the probability revision I've put up. Okay, these are a bit more challenging and you have to think a bit more. So, if you are doing the higher paper, it will help you to look at the questions and then see what to apply so that you don't get confused. Okay. Thank you to all my subscribers. Um, if you have not subscribed already, please subscribe. Okay. You can follow us on other platforms as well. I don't think it doesn't cost you anything. Okay, some platform is free to subscribe, some other platform is free to follow. It gets different names. Okay, please help us circulate the platforms, okay, so that we can get more people the help they need. Okay, and then if you subscribe, when you watch, when you receive, share, like, okay, follow, you can share as much as you want. Okay, it will be good. Okay, um please follow my notes/script. I always write this in the comment section. Okay, please follow the notes. Yesterday there was an incident where I wrote 6/35 and it was 9 out of 35. As I was going through it with you, I had to correct that on the notes, luckily. Okay, but if I didn't correct that and I saw it later whilst I was watching the video, then I have to correct it and put it in the notes. So just follow my notes, please. Okay, don't just say, oh, it's right, because at times, like 6 and 9, okay, there is a big difference. You can lose half mark or mark for that. Okay, so if it can happen to me, then it can happen to anybody. So please follow my note. And if the account is not yours, ask permission for the account holder before you use it to subscribe, share, like, or anything. Please ask permission or open your own account. Okay, and use it to follow us or subscribe or like and share and do whatever you want with it, because after all, it's your own account. Beware of scammers, please. Beware of scammers. Okay, don't allow people into your WhatsApp and Messenger and wherever have you, asking you for donation under this account. Please, it's not coming from here. If I haven't said it, it's not coming from me. They can edit the films. Now I know. Okay, they can edit it, take some part out, put some parts in. We are all still learning. Okay, so till I get to that point, at the moment, I'm telling you, and even if I get to that point, I'll still tell you. If I have to tell you to donate a charity, maybe I will link you to it, but it wouldn't be foreign numbers, personal numbers, personal accounts. It won't be that. Okay, if I have to subscribe, link you to maybe one of these charities that helps orphans and stuff, or Red Cross, or these big charities that we know, then I'm going to make sure that uh, they are officially in it. But if they're not officially in it, then and I haven't got anything like that doing. I'm not doing anything like that. Okay. Thank you very much. Recap. Watch last video for recap. We did a lot of probability question, tree diagram. Please watch it. Okay. Status, at the moment we are doing mental math with sets so that it can help you think a bit faster, because sets have a lot of multiplication work in it, factors and stuff. So it's you have to reason things out quickly. So please um, watch it, okay, to help you. So today's is also simplifying mental math using sets. Okay, I have some few here for you. 4 root 24 times 2 root 5. Okay, now root 24 can be written as root 6 times root 4. So 4 root 24 will be 4 times root 6 times 4 times 2 root 25. Okay, now if you look at this carefully, okay, 4 times 2 is 8, root 4 is 2, so it will be 16. Root 6 and root 5 is root 30, so you have 16 root 30. Okay, so we simplify this 2 into that. Now the second one is 2 root 63 times 2 root 7. So 2 times 2 is 4. Root 63 can be written as root 7 times root 9. And then we have root 7 here, root 7. Root 7 is 7. So 12, 4 times 3 is 12. 4 times 7, root 7 is 28. Root 9 is 3. So if you look at it this way, 3 times 7 is 21 times 4. 21 4 times. Okay, so if you double 21, you have 42. If you double it again, you have 84. Assuming you don't have the calculator to solve this. So that will be your answer. 4 root 6 divided by 2 root 2. Now, 14. Okay, 14 divided by 2 is 7. So that part will be 7. 6 divided by root 3. Okay, you can write 6 as 3 times 2. So the root 2 will cancel. So you'll be left with root 3. So 7 root 3. 2 root 98 times 2 root 2. Okay, so 2 times 2 is 4. 98 can be written as 49 times 2. And then you have a root 2 here. Now another root 2 is 2. So 4 times this 2 here will give you 8. Root 49 is 7, because 7 times 7 is 49. So 8 times 7 is 56. So everything here has been reduced to 56. Now, 2 root 8 times 2 root 8. So 2 times 2 is 4. Root 8 times root 8 is 8. So 4 times 8 is 32. Okay. So everything here has been reduced to 32, simplified to 32. Okay. You are making your answer simpler. Okay. Now today we are going to look at more probability examples. Okay. And then after this, I think uh, the rest will do it for starters, or if it's a bit complicated, we'll use it and add it to the next set of possible exam questions. Okay. Mercy has a box of counters: green, red, and blue. These are the type of questions you should expect: sweet, counters, cube, in sports, swimming, race, netball. Okay, the probability can come as a fraction or as a decimal. But note, probability is always or as a percentage. But it's always up to 1 or 100%. It doesn't go beyond that. Okay, so if you get an answer beyond that, then you are likely wrong. Messi has a box of counters: green, red, and blue. Messi picks one at random. Okay, so he picks one from his box. Here is the summary in a table. Okay, so he has the counters, and then the green is 0.6. That is the probability of the green in the of the counters in the box. That is the probability of the red. So if you add these two and take away from 1, you get 0.15. This wasn't given. Okay, this wasn't given. I calculated it myself. Okay, this part also wasn't given, but I'll show you what I did. Okay, now find the probability. Mercy picks a blue counter. So the only way she can pick a blue counter is if we know that. So if the total probability will be 1, so if I take 0.6, if I add 0.6 plus 0.25, then I'll get 0.85, and then I'll subtract it for 1, which is 0.15. So for Mercy to pick a blue counter, that is her probability. Okay. If 10 red counters are in Mercy's box, okay, find how many green Mercy has. Now, what they are saying is 0.25 will represent 10. Okay, so how many would green get? So straight away, you can see that if 0.25 is 10, then 0.50 will be 20. But this is 0.60. So to find the other 0.1, okay, so we know that this is more than 20 because that is 10. So to find the other, you can do the cross multiplication, or the equivalent multiplication. So 10 equals 0.5. So how many will be 0.6? So you have 0.6 times 10 divided by 0.25. Okay, now 10 times 0.6 will be 6 divided by 0.25. So I'm going to add two zeros to the top, and then this becomes 25. Or I'm going to just move the decimal 1, 2 places, and move it 2 places, both numerator and denominator. So I have 600 divided by 25, which is 24. So there'll be green, there'll be green in the box. Okay, there'll be green counters in the box, 24 green counters. So this is why I've written 24 here. Okay, and we've been told there are 10. Now, how did I get this? It's in the other question, but if 0.25 is 10, another 0.25 will be 10, another 0.25 will be 10, and another 0.25 will be 10. Probability is not is always up to 1. So if that represents 1, then 10 plus 10 plus 10 plus 10 will be 40. So if I multiply 10 4 times, there are 40 in the back. Okay, so that's why we've just calculated there are 24 greens and there are 10 red, which we've been told. So if there are 24 greens and 10 red, and I can see that there are 40 in the back, then there'll be 6 blues. Okay, so this is the analogy I did. I have time, so I can do that. But let's see the other questions as well. How many blues? Okay, so you can either do what I just showed you, okay, to get 6 blues, or again, if 10 equals 0.25, we know the probability of blue is 0.15. I taught this method, cross multiplication, in the earlier videos. Okay, so you can have 0.15 times 10, or 0.15 times 10, okay, which is 1.5 divided by 0.25. So now the decimal is here, so I'm going to shift it 1, 2, and then do the same for the denominator, 1, 2. Numerator becomes 150, denominator becomes 0.25. Okay, so 150 divided by 25 is 6 blues. Okay, so whichever way you do it, there are 40 in the bag. Okay, there are 40 in the bag, 24 greens, 10 red, and 6 blues. Okay. Mercy picks a counter at random and replaces it back into the box. Complete the tree diagram. So here again, we are going to use the information we've given. Okay, so she picks a counter, so we are going to use the green. Okay, so now the probability of choosing a green from this, because initially they just give us red and green and red. Okay, so if she chooses one and is green, then the probability of choosing a red or a blue or not a green will be 0.4. Okay, so I'm going to use that reasoning to do a tree diagram. Okay, I could use something else to form the tree diagram, but I want it to be easier. So if she picks a counter at random and replaces it, um, so I can use red, but I'm going to use green. So green is 0.6. So if it's not green, then it will be 0.4. So that I can add up to 1. Okay, we are still talking about what we are doing earlier. Okay, now, so if it's green and green again, then it's 0.6. Okay, because here she replaces it. She replaces it back into the box. Okay, and it's good because if she didn't replace it, then we have to use the fraction form. Okay, we have to change this to 6/10, or we have to use 24/4c. So, yeah, but now she replaces it, so we don't have to worry about that aspect. Okay. So, the green is, to get a green first, is 0.6. Not a green, any other color will be 0.4. Then the second pick, to get another green, 0.6. Not a green, 0.4. Another green, 0.6. Not a green, 0.4. Okay. So this will be how the tree diagram for Mercy will look if you are using considering green. Okay. Now from diagram, find the probability of a green and a green. So the probability of getting a green and a green is here. 0.6 times 0.6. This is the only time, first time green, second time green, which will give you 0.36. This is here. Probability of green and not green in any order. This is where the end log come in. First she picks green, not a green, and then add not a green and then green. Okay, so this is 0.24. There another 0.24, but I have to add, so your probability now be 0.48. Probability of both not green. Okay, so if both are not going to be green, then it will be either red or blue. Okay, so this is where the tree diagram help. Okay, so it will, so not green and not green. So if it's not green, if you look at our table, here it is. Not green is 0.4. Not green is 0.4 in second instance. Okay, so not green and another not green will be 0.4 times 0.4, which will be 0.16. Okay, 4 times 4 is 16. One decimal place, another decimal place, so it will be 0.16. Okay, probability is that at least one is green. So if probability is at least one green, okay, so she can pick a green and not green, so that would be one green, or not green and green, that is also one green, or both greens, because it says at least. So even if she picks two green, that is at least one green. Okay, but whatever she pick the first time and the second time, there should be an instant where there is green. So that is where you have these three. So green and not green is 0.6 times 0.4 from the tree diagram which I've shown you earlier. Okay, not green and green, or so you add, will be another 0.24, 0.4 times 0.6, and then both greens will be 0.6 times 0.6 here. Okay. So your answer will be 0.24, add 0.24, add 0.36, which will be 0.48, add 0.36, okay, which will give you 0.84. So here, this is the what we guess is the last bit. That is the tree diagram I gave you. So you could have done the tree diagram red and not red, okay? But the questions here involves green. So if you read it to the end, if you had done a tree diagram using red, it still represents the information, but it will be difficult for you to get all this information. Okay, so the best one is to do the green tree diagram, and then the others not green, because I could as well done a tree diagram of red, not red, okay, or blue, not blue. But what I realized that the questions that follows, most of them were asking me about green. Okay, so I'll rather you do a tree diagram using greens and then use that to solve the question that I've just walked you through. Okay, so at times, questions like this is easy, but if you can't um, do it straight away, you haven't done it before, or you are not familiar with it, it's better to leave it to the end, because maybe you have to read the question to the end before you draw your tree diagram. Immediately you do, because assuming I did a tree diagram, red, not red, I have to represent the information on a tree diagram, but it will not help me with the questions that follow. I hope you get what I mean. So after I've read through the questions, because maybe this is the second part of the question, okay, I realized that most of the questions are greens. They're asking me more questions on green. So if I do the tree diagram in green, then I can answer all this, because find the probability of green and a green. Find the probability of green and not green. Find the probability of both not green. Find the probability at least one is green. And then before then, they said complete a tree diagram. So if I'm going to answer all these questions, finding greens, why am I doing a tree diagram uh, with red or not red, or with blue and not blue? Because it represents the information, but it doesn't help me solve the questions that follow. You get what I mean? Okay. So that is why I brought this example to show you today. So questions like this, they carry maybe some marks which you don't want to lose. So if you are not sure what to do, yes, you know how to draw a tree diagram, but how would it help you get your answer as quick as possible? Because if you could represent the tree diagram, information the tree diagram, then you don't have any issues. You can easily reason some of this out, because your reasoning will tell you when to multiply and when to add. Okay, so this is why I brought this example to do it. Okay, sadly, I might not do, maybe I might do another set of revision earlier if I see some more challenges of later on. But I've done a lot. That this is our eight, and then if I have any more, I'll just put it on some possible questions. Okay, so that people will be doing it next year will benefit from it. Is that okay? But if you're writing your exam this season, very good luck, please. Not just maths, all your subjects. Okay. Uh, Thank you very much. Okay, please subscribe, share, like, follow, do whatever you want to, you can do to help us push the message across. Okay, thank you very much for watching our video today, and I'll see you in the next